In this video, we will try to understand four important fundamentals. The first one is Lambda expressions. The second one is generic action delegate, generic func delegate, and generic predicate delegate. So what we'll do is, we'll try to understand these four important concepts, and we'll do some practicals, and we'll see that where we can make use of these four concepts. Now the first important place where you will be using these four principles is when you want to make your delegate code shorter, sweeter, and simpler. So one of the places where you will be using Lambda expressions, action generic delegate, func generic delegate, and predicate generic delegate is when you want to make your delegate code more simpler. So we're going to see a demonstration later on the same. The second place where Lambda expression specifically is very useful is to create expression trees. Now we're going to talk about expression trees in detail later on, but you can see the implementation of expression trees in LinkU as well as business languages. So these are the two places where you will be using these four principles. So the first place is when you want to make your delegate code more simpler, and the second place is when you want to go and build expression trees. So let's go and see the first important use practically. So in order to see that how actually your delegate code can be made more simpler, you can see that I have created a very simple function here called as calculate area, and this calculate area function actually takes up a radius and it uses the pi r square formula to calculate the area. Right, now what we'll do is we'll go and create a very simple delegate here. You can see that I'm creating a delegate here called as cal pointer, cal r pointer, cal area pointer. Actually that's what it was supposed to be meant to be, and I'm going to go and create a object of this cal r pointer. So I'll give a name as c pointer, and I will point that c pointer to the calculate area function. Now we can always go and invoke the delegate by using the c pointer dot invoke. The dot invoke function actually helps you to go and invoke the delegate. So we can say dot invoke, and we can give a radius over here, and this will actually help us to calculate the area. Now let me just put a debug point here, and let me just show you the value. So you can see that there my debug point is, and you can see that the area has been calculated. So a very simple function we have created called as calculate area. We have created a delegate called as c pointer, and you can see that we have invoked it by using the invoke function of the delegate, and it calculated the area for us. Now let's try to see that how we can use Lambda expressions and other delegates to make this code more simpler. Now before we move ahead and we talk about Lambda expressions, right, I would like to just give a small pause here, and I would like to talk about something called as anonymous methods. Now anonymous methods was one more attempt made in order to make your delegate code more simple. So let's first talk about anonymous methods, and then I will go towards Lambda expressions and the other three generic delegates. Right, so you can see over here I have gone ahead and I've commented the cal r pointer c pointer declaration. Now what you can do is you can take this object c pointer, and you can go and create the object of the c pointer here, and then you can straightforward write here delegate. Okay, you don't need to create a special function here called as calculate area. Here itself in the inline code you can go and write delegate, and you can go and put the code of the area calculation inside the inline delegate. So I can do a control C and a control V here, and I can completely get rid of that separate function called as calculate area. So you can see that our delegate code now will be simpler, because we don't need to create a separate function called as calculate area here. The function is now currently inline, so that really reduces a lot of code to create a separate function. So if you run this again, the output will be absolutely same. So if I go and I'll just go and declare a variable here called as area, and I will go and invoke this c pointer anonymous delegate, okay, or anonymous method. So if I see this value here, you can see that my area calculation is currently the same 1256. So you can see that by using anonymous methods, how we have got rid of that extra function which we had to create when we were using a normal delegate. Now let's go and see that how Lambda expressions can make this code more simpler. So first let's go ahead and comment this code over here, and now let's go ahead and create let's see that how we can create more shorter and sweeter syntaxes by using Lambda expression. So the first thing is we'll say okay cal r pointer c pointer, and we'll declare a variable here called as r, and after the r we have to type r and then say equal to greater than sign 3.12 into r into r. Okay, so you can see at the end of the day, Lambda expression is nothing but a simple inline code. It actually points towards the inline code. Now this inline code can be pointed later on using a delegate, but Lambda expression at the end of the day points towards a single line of code. Now you can see that Lambda expression is divided into two parts. First, whatever is after the equal to and greater than sign is nothing but the line of code, and whatever is before that indicates the input parameters. Now Lambda expression understands the variable types by looking at the calculation part. So for example, over here he has understood, yes, the r variable, the input r variable can be integer and the return type can be a double. So he actually understands by looking at the code, that what kind of data type this variable will have. So you can see that currently we have created a very simple Lambda expression, and that Lambda expression currently is pointed by using a delegate called as C pointer, right? So now if I go ahead and if I can go and invoke this C pointer delegate, which is pointing towards the Lambda expression. So I can just go and say C pointer of 20 and run this code here, and at the end of the day, he will give me the same output what we were getting previously. Okay, so you can see that how we have gone ahead and we have minimized the lines of code by using Lambda expressions. Now we'll see that how we can go ahead and further minimize this code by using our generic delegates. So by using the generic delegates, we can go and further minimize this code. So let's go ahead and delete all of these things, because we're going to make our code more shorter and sweeter. So let's see that how we can go and use Lambda plus func. So in this we're going to see that how we can use the generic delegate called as func and minimize our code. Now what basically is a func here? Okay, now func is nothing but basically it's a generic delegate. It's a ready-made delegate, and this ready-made delegate actually you can define inputs and outputs of different data types to this ready-made delegate here. For example, for now, what we need is a double as a input and the double as a output. Okay, so you can see that I can go ahead and declare this delegate here, and it is absolutely same as declaring a simple delegate. Okay, so I can go and say, okay, func, this is going to go and return back a double as well as take input as a double, and I can also as well as get rid of that function here. So you can see that literally our code has become only 2 lines of code. Okay, from the, if you remember right, the first code which we talked about, and the code now we are talking about using Lambda expression and the func general delegate, it's become quite shorter, right? So if you go and run this again, the output will be same, but only that it is currently using Lambda plus your function generic delegate. Okay, so there you go, and you can see that the value is almost same there, right? So you can see that how we have used the func plus the Lambda expression to go and minimize like 4 to 5 lines of code of delegate into just 1 line of code. Now we'll also go ahead and we talk about 2 other generic delegates, that is action and predicate. Now there is one more important delegate here called as action, a ready-made generic delegate here called as action. Now if you see the func delegate, the func generic ready-made delegate, it takes up any input and it gives out output. So for example, in our case, it was taking up double as a input as well as it was giving out double as output. So the first double actually indicates input, and the second double actually indicates the output. Now many times you want to point towards function which have no output. It can have some inputs but it doesn't have any kind of output. In other words, the return type of those methods or functions is always void. So for those kind of methods and functions, we can use something called as the action generic delegate. So what you can do is that you can go ahead and you can create a simple action delegate. So what we'll do is, for understanding purpose, let's go ahead and create a simple action delegate which takes up a string here. We'll give a name to this delegate as my action, and what we'll do is we'll say that okay, this takes up a variable called as y here. Now this y is actually a it's a string, string because we're going to do a console.write. So you can see that we have created a very simple action delegate here called as my action, which takes up a string variable called as y, and what it does is, it actually goes and writes to the console application or to the console prompt. So in other words, we are not expecting any output from here, we are not expecting any return type from this function here, but we are just basically expecting to go and execute this action and expect some output. So if we go and now we can go and invoke this my action here. So what I'll do is I'll go and type here my action, and we'll say hello. Okay, so what should happen now is, if I go and run this application, or if I go and run this program here, it should actually go and display the hello on the console prompt. So let me just go and put a debug point here, and let me do a F5. So there it goes, and there my action is getting executed, and you can see the hello over there. So you can see that basically by using the action delegate, I was able to point towards a function where I'm not expecting any kind of output, but I'm going to just give some input and some action should take place. Now there is one more kind of delegate which is again a ready-made generic delegate, which is again very important, and that is nothing but the predicate. Now predicate, you can think about it's an extension to the func. So in func, what happens is you can have inputs as well as you can have outputs. Now predicate, you can think about it's only for checking purpose. In other words, sometimes what happens is you just want to check if the return type is true and false, and probably the input can be anything. Okay, so for example, you can see that over here there is only one input, so you can have input here of any type, can be string, integer. So but the return type will always be boolean. So in other words, as the name says predicate, predicate will always return a type of boolean, and it can take any input type. So you can see that I'm going ahead and I'm creating a predicate delegate here called a check greater than 5, and I'm going to go and create a lambda expression. Now this lambda expression actually just goes and checks if this length is greater than 5, then this predicate will return true, or else it will return false. Okay, now I can go and invoke this ready-made predicate delegate here. So I can go and let's say I can go and pass here shiv1 to 3. So that means this length is definitely greater than 5, so I should get output as true. Okay, so if I go and put a debug point here, and if I try to run this application, so I'm going to just say console.write line here, and let me go and put a debug point here. So I'm going to put a debug point F5, and now shiv1 to 3 is definitely greater than 5, so you can see that the value is true. So in other words, we have three kinds of generic delegates or ready-made generic delegates. The first one is func, where you are basically trying to give some input and you are expecting some outputs. Okay. Second is action, where you are just going to give some inputs and there is no output as such, from those methods, like methods, which actually return void. And the last one is predicate, which is actually, it's one of the forms of func, where basically, you give some input and the output is always boolean, that is true and false. So quickly revising, so what we are saying is that functions will be used to point towards methods, where you can expect, where the input type can be anything and the output type can be anything. Action you will use, where the method is not giving out any type, like void, and it is taking some inputs. And predicate you will use, where the return type is always boolean and the input type can be anything, right? So these are all ready-made generic delegates. Now the next question, we should start asking ourselves is, so is this the reason why we would like to use lambda expressions and these generic delegates? If this is the reason, then I'm sure that many developers will not buy it out, because reducing 3 lines of codes to 1 line of code is not the big reason to use any functionality, right? But there is one big use where I find these these things very useful. If you see in the recent times, the classes which are coming out from .NET, right? These classes are heavily using these delegates like anything. For example, let's take up the example of a list here. So let me just go ahead and create a very simple list of strings here, and let me show you, how the current classes of .NET are leveraging these delegates to make your code more better and readable. Now you can see that I'm creating a simple list here, and in this list I'm going to go and add two elements. One is Shiv and the other one is Shiv 1, 2, 3. Now if you watch very closely here, now let's say just say here o string str o string dot find. Now if you see here, you can see this find, right? It actually takes up a predicate. In other words, it takes up a function, and if you go and give him any predicate, what this list will do is it will actually take that predicate and pass the values of the items to that predicate and evaluate if it matches the predicate condition or not. For example, I can go and take that top predicate which we have just created, that is check greater than 5, and I can pass that predicate to this find function here, and then later what this list will do is it will take every value that is Shiv, it will give it to the check greater than 5, it will give Shiv 1, 2, 3 to check greater than 5, and wherever that predicate matches, only those output will be displayed. So for example, if I pass him that predicate that is check greater than 5 to this find function here, so let me do that, and if I go and run this code here, so I'm going to just say here console.writeLine, and I will just display str. So what he will do is it will actually display me Shiv 1, 2, 3. So if I just go and also, like if you wish, right, you can see here there are other places also where these delegates are used. For example, you can see that I have said o string.any here. You can see that it's taking up a func, right? So in other words, these delegates are definitely useful where we would like to go and pass these predicates, pass these actions, pass this func, and basically those elements will take these delegates and act upon it. So currently we'll just see that how that check greater than 5 predicate runs inside this list here. So if I go and run this thing here, let me go and just go and delete this. Let me put a debug point here and let me do F5. Now you can see the output is Shiv 1, 2, 3. In other words, what has happened is that check greater than 5 predicate delegate is taken, and every element of the list is passed to that check greater than 5, and it is checked that if the length is greater than 5 or not, and whichever element has the length greater than 5, that element is then sent to that string str variable. Now when we started this video, we said that there are two important uses of lambda expression. One is that definitely it helps your delegate code to be made more simpler, and there is other important use of lambda expression, and that is expression trees. Okay, now before we move ahead, let's talk about what exactly is the meaning of expression trees. Now in order to understand expression trees, let's take up a simple example here. Let's say that we want to do something like this, 10 plus 20 plus 5 plus 3, or I'll say rather, let's say that we want to make a very generic calculator, where the end user can go to the application and he can start putting like 10 plus 20 minus 5 plus 3 plus 10 plus into 10, and he says enter, and then the value should be displayed. Now in this kind of scenario, if you have to do it, probably without using any help of lambda expressions, probably you'll put a lot of if conditions, you'll put some collections, you'll write some logic, and you'll try to manage it. The other way is that basically you can go and build up expression tree here, so probably whatever the user has passed to you, you can go and construct expression tree, and then you can go and evaluate that expression tree and run it. So in other words, what I can do really here is that I can go ahead and say, okay, at the top there is one expression tree which actually will, or one node in the tree which will actually help me to do subtraction, right? And there is one node where I will go and do addition. So actually there are two nodes where we'll do additions. So this is the first node, and to this addition node I'll give two inputs like 5 and 3, right? And in the same way you can go ahead and put one more node here of addition here must be, and this belongs to the second thing, that is 10 plus 20, and again to this add node I can go and provide 10 and 20 variable, right? And finally both of these what you call nodes actually go and connect to the subtract node. So if I can go and construct such kind of expression tree dynamically, right, and then I can if I have a facility where I can go ahead and take this expression tree and create a delegate out of it and then go and execute it, then that would really make things more dynamic, right? And that's possible by using expression trees, or I'll say lambda expressions. So let's go ahead and create the same expression tree what we have discussed, that is 10 plus 20 minus 5 plus 3. So the first thing what we have to do is we have to go and import system.linQ.expression namespace. Now what I'll do is I'll go one by one. So first I will go and create the left hand expression, that is adding 10 plus 20. So you can see that I've created what you call a binary expression here called as B1, and this B1, what it does is it will go and create a simple what you call a binary calculation here, which is a type of addition, and it will take two input variables. One is 10 and the other one is 20. So it will say expression type dot constant, one will be expression dot constant, one will be 10 and the other one is 20. So B1 is nothing but it's the first leg of the tree, where basically it's going to go and add 10 plus 20. In the same way, we have to create the second leg of the tree, which does the addition of 5 plus 3. So what I'll do is I'll go and do a control C and control V here, and I will create one more expression here called as B2. This expression again does addition. Only thing is that it's going to go and add 5 and 3. Now both these expressions I'm going to go and feed to an expression called as subtraction. So I'm going to go and create an expression called as B3, and this B3, what he will do is he will do the subtraction of B1 and B2. So in other words, he's going to take he's going to go and evaluate B1, he's going to go and evaluate B2, and he's going to go and subtract both of them and create an expression called as B3, right? So very quickly here, the first expression B1 does 10 plus 20, the second expression B2 does 5 plus 3, and the last expression actually goes ahead and does the complete thing, that is it subtracts B1 and B2. Right, so there we have created our expression tree. Now the next thing is, using this expression tree, we would like to go and create a lambda expression out of this, and we would like to go and invoke it. So you can see that I am saying, so in order to create a lambda expression, evaluating this tree, what I'm saying is expression.lambda, and I'm expecting a delegate of type func, which is going to go and return back a simple integer, and I'm saying that please go ahead and run B3, and that means compile B3. Now the time I say go and compile B3, it will actually go and invoke that it will go and parse the tree and invoke the node, and it will start evaluating each node, and then finally it will give out the output. So the time I'm saying B3.compile there, it's going to go and execute all those expression tree from the bottom, and it's going to go and display me the result in my int result variable. Alright, so in this variable, we are going to get the result. So this statement, what you see, right, expression.lambda.compile is nothing but it actually goes and creates a delegate by parsing the expression tree which we have created using B1, B2 and B3. So let's go ahead and put a debug point here, and let's see the output, so that we are satisfied that this expression tree is working properly. So there you can see the result. So the result is 10 plus 20, that is 30, 5 plus 3 is equal to 8, so 30 minus 8 is equal to 22. So that's perfectly right. So you can see that one of the biggest benefit of lambda expression is that you can go and create an expression tree. Now remember that expression tree is not delegate. Expression tree, you can construct dynamically, and you can go and create a delegate out of it. The most important use of expression tree is when you are creating what you call end user languages. Like for example, probably you would like to give a facility to your end user, where the end user goes and types some commands in simple English, and using that English you would like to go and build up expression tree, and this expression tree you would like to go and create a code which can be in a form of a delegate, it can be in a form of a function or a class or whatever it is. So if you want to go and create end user languages, right, which wherein the end user can go and write in simple English, and that English you would like to go and create commands and fire on your system, then definitely the expression tree is very useful. For example, one of the what you call favorite what you call business languages is SQL. So if you see SQL, when you write select star from table name, where this, union or inner join or whatever it is, what the SQL server does is it actually takes that SQL language and it goes and it creates a tree and then goes and executes on your database, right? So in other words, if you want to go and translate your simple English into code solution, then definitely Lambda expression tree is a preferred way of doing it. It's an easy way of doing it, and also you can find some of those what you call ready-made use already. Lambda expression is used. Is one of them is LINQ. In LINQ, when you write a LINQ, a LINQ query, it actually goes and builds up an expression tree, and then this expression tree is evaluated and it can be converted into SQL or any other data source language. So for example, if you're using LINQ to SQL, you'll find that expression tree is used like anything. So it goes and it parses that LINQ query and then creates an expression tree out of it, and then basically goes and generates SQL using this expression tree. So LINQ is one of those places where this what you call expression tree is used heavily. Let's go and see a simple demonstration of how LINQ uses expression tree. So you can see that here's a very simple LINQ query I have. This LINQ query, if you see what it is doing is it is going and firing on the customer tables a simple LINQ query where I'm going to go and say that okay, go and return me back customer name whose name is Shiv. Okay, now if you go and run this, right, and if you take that X value and if you go and put it in a quick watch, so let me just go and put that in a quick watch there. And if I copy that, right, if I do Control A, Control C, and if I put that in Notepad, right, so let me just start run Notepad, and if I put that Control V that, you can see now how that LINQ query has been translated into SQL. You can see the LINQ query says from whatever it is, from I in what you call O dot customer tables, and then where I dot customer name is equal to this and this, but that whole thing has been translated into a simple select statement there. You can see select customer name, country and gender from customer table where customer name is equal to @ whatever it is variable. So one of the biggest use where Lambda expression is used is in LINQ. Okay, so I hope that you have enjoyed this video. In this video we saw that how we can make use of Lambda expressions, action, func and predicate delegate. So so next time whenever you see one of those delegates like action, predicate or func, or you see a Lambda expression, remember two things. One is that they are used for shortening the delegate code. Second is very rare use you can ever make, probably you will ever need it, that is creating expression trees and then generating a delegate out of it. Thank you very much.